Okay, have you ever take a crazy looking integral from the UNSW integration bee 2024, problem 15? We have the integral of arctan of x to the x squared times 1 plus 2x arctan x natural log arctan x dx. Okay, to get started with this, at first this is looking really impossible, and particularly the troubling part maybe is this first term. Just looking at this, how often do you see arctan with not only an exponent but then x squared as the exponent? What I tend to do when we have an impossible integral like this, particularly when we have an impossible looking term, let's take the derivative of this. And just looking at what we have over here, it's kind of promising because we've got arctan here and here. So it makes me think, I mean, ideally what I'd like to happen is like to do a u substitution. If this was u, it'd be nice if this was the derivative. So if this is the case, this is actually not going to be too bad. So let's try this. I'm just going to go ahead and guess. I'm going to do a u substitution for this piece right here. But to take this derivative is actually a little bit complicated. You can't just use power rule when you have x squared in the exponent. So what we want to do is kind of use this way to rearrange the base. We use this a lot where if we have a base of a, in this case it's going to be this arctan x, we can write this as e ln a. So doing this over here for our u value, rewriting this, we're going to have e natural log of all this arctan of x, and then we still have this x squared. By exponent properties, we can multiply it in. I'll bring it in front here like this. But now that we have it like this, we can actually take the derivative of this because e to anything, we can start with just repeating it. So we can write it as e x squared natural log arctan of x. And then we can just use the product rule on this part. So first we'll take the derivative of x squared, we get 2x, and just bring down this natural log arctan x. And then I'm kind of out of space, let me bring it down to a second line. So then we're going to add the second part. We're going to bring down the x squared and take the derivative of this. Derivative of this, natural log of something, it's going to be 1 over arctan x. And then we need the chain rule. With the chain rule on this, we just get a 1 over x squared plus 1. So as you can see, this derivative is pretty complicated looking. Now let me come down here and try to clean this up. Now for this first piece, this is actually what we arranged. So this is actually the same thing as this, which is our u. So we can put it back into this form. And I can write this as arctan of x, x squared. And then for all this in blue, there's not much I can do but just kind of copy it over. And now taking a look at our du value, it's not terrible. What we have some matches. I mean, we have this piece here, which is this. That's good. Then with this piece here, we're kind of matching. We have the 2x here. We have this natural log tan x. So that's pretty good that we created that. But we're missing this thing right here. And then also this piece right here, this doesn't really match anything. So I'm not sure what's happening there, where this is definitely not 1. So this part's a problem. So I did it this way first on paper and it clearly wasn't working. And one thing I noticed though, just here, if this was actually x squared plus 1, then we'd have cancellation. So then if that happened, we're getting closer. And so it was this right here that made me think, going back to the u substitution we tried, what if we tried x squared plus 1? Because I think if we do that, we get this cancellation. But then this is also the same thing as multiplying by another copy of arctan x. And my thinking was, okay, if we had another copy of arctan x and you multiply that in, that would cancel this one off here and it would create this one here in this spot. So the thinking is if we just add a plus 1 on this, this could work. Okay, now starting over with our u substitution with the x squared plus 1 in the exponent now. I know this is kind of sketchy, right, because we don't have it anywhere in our problem. But from what we saw with that derivative, it seems like it could work. So first what I want to do is the same trick we did before and rewrite this in the exponential format. So changing this to e natural log arctan of x. And then we're just going to multiply on this x squared plus 1 in front here. And then for our du, let's take our derivative again. But instead of copying this down, I'm going to do that switch and put it back into this form right away. So we're going to have this part coming down of just arctan x to the x squared plus 1. But then we're going to need chain rule to integrate this with the product rule. So what's going to happen here is we'll integrate the first part, this x squared plus 1. That's going to give me 2x. We'll bring down the second piece, natural log arctan of x. Then for the next part, we'll bring down the x squared plus 1 and make it clear in parentheses. Then take the derivative here. This is going to give me 1 over arctan of x. Then chain rule derivative of arctan of x. This is going to give me 1 over x squared plus 1. Put the dx on the end. Now here we get that cancellation that we set up. We want the x squared plus 1s to cancel. We again have this stuff that we had before, so that's good news. Now what we want to do, again, what I said before is This right here can be written. So for our du, we can rewrite this and break out the plus 1. So what I can do is write this as arctan of x to the x squared. That's this piece right here. And then multiply it with this plus 1, break it out with exponent properties, and then we can have this arctan of x here, and then we have all this stuff. But now we can just take this arctan and distribute it inside the parentheses. When we do that, it's just going to cancel with this one. So this term, we're just going to be left with a 1. So now let's clean it up and see what we have. So we have here in front the arctan of x to the x squared. That's a good match there. We distribute this into this first term. We end up with 2x arctan of x times, just changing the order a little bit, times natural log arctan x. And we already canceled this, so this just gives me a plus 1 right here. And we have our dx. But what do we notice? Everything we have right here, this whole du value, this is our whole integral. This is everything. So this whole integral just reduces to just du. For this one right here, we have it out of order, and I've got this plus 1 down here, but it's still the same thing as our integral. So all we're left to do is integrate du and finish it off. So now we can just go ahead and integrate this thing. Integrating 1, this is just going to give me u. So all we need to do here is just back substitute in order to finish it off. So for my final solution of this, we just get this, which is arctan of x to the x squared plus 1, add a plus c, and that's it. Okay, there you have it. Crazy integral from UNSW 2024. Thanks everyone for watching. Have a good day.